This is a video presentation for COA Lab 3, Part 1 and Program 1. This is from Section 01, Group 2, and in this program, I'll explain how to calculate the parameter of two hexagons using loop and add instructions. So first thing first, we look at the dot data, and we have a few instruction or string instruction here. The first one is the description to display the description or the title of this program, and it's already here since I already run it. And also we have prompt 1 and prompt 2 asking for the user to give an input for the side length of hexagon 1 and hexagon 2. And also we have the result. This line is shown at the output before we want to show the actual value of the parameter of hexagon 1 and 2. And also the total line, this one is for this line should show before we show the value of the total parameter of hexagon 1 and 2, which is the sum of this two. And then we have three variable here. First we have parameter hexagon 1, and then parameter hexagon 2, and the total parameter. This one should store the sum of these two, and all these three variables, they are all dword. And next we move on to dot code. In line 20, we start with setting the register ECX or the counter equal to 6, because a hexagon has 6 edges. So this is to use in our loop so that it can loop so that it will loop 6 times, and by the end of this loop we will get the parameter of the hexagon. So moving on to line 22, first we move this offset of description, this line we move to the edx, and then we write the string at the output. So that's what we have here, and then we call an end line so that we have a gap here. And next we move the offset of prompt 1, which shows input hexagon 1 side length, and we call the write string to display it at output here. And then the next line we call the read decimal value. So let's give a value, for example 6 or 7, sorry, what? And then in line 29 we move this value. So this 7 is read to EAX, and then we want to move this value into the variable parameter hexagon 1. And then next we call in line 31 we call the offset of prompt 2, and then we call we move the offset of prompt 2 inside edx, and then we call the write string so that it will display a prompt to ask the user for an input. So we also call read decimal, just like what we do for hexagon 1. So let's give a value, for example 8. Oops. Okay, so just ignore all this first while I explain. And then small, where do I stop? I stop here. Read decimal at line 33. So we read the value 8, and then we store it to the variable parameter hexagon 2. And in line 36, we clear the value inside EAX, and this is to make sure there's no what do you call any cache value inside the register. And so for line 39, we will add the value of the side length of hexagon 1 into EAX, and we will loop this operation for 6 times. So by the end of this loop, the value stored in the register EAX should equal to the parameter of hexagon 1. Since it's still in EAX, so we have to move it back to parameter hexagon 1. And so in line 44, what we do is we clear the value inside the register again, and we reset the counter ECX back to 6, and we loop the same thing for hexagon 2. So in this line, we get at the end of this loop, we get the parameter of hexagon 2 is in EAX, and we move it back to parameter hexagon 2 variable. And next, we move to line 53. We move the offset of result, which is this line above, result of parameter hexagon 1 and 2. We move this line into EDX, and we write the string. So it is shown here, result of parameter hexagon 1 and 2, and then we call an end line. And next, we move the parameter hexagon 1 to EAX, and then we display the value here at output. We call the right decimal. So it's shown here 42, and then we've an end line. And the same thing for hexagon 2. We have two end line here, so 1 and 2. And next, we move this total line, this instructions, and then we call the right string, so it's displayed at output, total parameter hexagon 1 and 2. And the next is, so for this one, at line 61, we have moved the parameter of hexagon 2 into EAX. So what we have in EAX now is the parameter of hexagon 2, and we total that up with parameter of hexagon 1, and then it is stored in EAX. So we call the right decimal, and we display what the value inside EAX, which is 90, which is the sum of 42 and 48. And then we call an end line here, and that's it for program 1 of part 1. We will continue with program 2.
Good day to Dr. Ford. This is my video submission for Lab 3, and I will be presenting Lab 3, Part 1C, Program 2. So for Program 2, we need to write a program that will interactively ask the user to input the values of 6 integers in dword and put the values into an array named hello. And then next, we will look at the indexes of the values inside this array and then add up the odd ones into a variable called total odd and the even ones in a variable called total even. And we will display the output as such. So this is the program that I have written. To create the array, I've written hello dword to specify the size, and then duplicate 6, and I filled it all with zeros. And then I created a total even variable that is of size dword with initializer of 0, total odd size of dword with initialization of 0, and a few strings I've written here with different variable names. So description, a prompt, a result, and a result for the even total and a result for the odd total. And this will all serve as prompts to ask user for input or to be more descriptive about what the output is that is written on the console screen. So moving on, first what we do is we move to EDX the offset of description. So and then we call write string so that it will write the string to the console, and then we call CRLF for a new line, and then we move ESI. We move to ESI the offset of the array hello, and we move 0 to EBX, and all these initializations are useful for later when we want to do pointer-based referencing. So, and then we move 6 to the ECX or the counter register. So at the counter, we put 6 at the counter register is because we want to, the hello array has 6 items. So we want to loop through the read loop 6 times. So first we move to EDX, the offset of prompt, to prompt the user. We call write string, and we call read decimal to read the decimal that the user has put in. And then we move a dword size pointer of ESI plus EBX. So we move the value in EAX into this. And what this does is that, so first the ESI has offset of the hello. So it would hold the address of hello at the first value of hello, or hello at index 0. And so we are going to put what we have read from the user through keyboard input and store it inside this element of the array right here. And then we add 4 to EBX. EBX was first initialized to 0, but now we add 4 to EBX so that the next time when it loops, this when we move the value inside EAX into the uh, hello array, it will now be pointing to the second item in the hello array with which is offsetted by 4 from the initial address. So this will loop 6 times for us to enter all the values into the array hello. And then next we will move 3 to ECX, so the counter is now set to 3. We move back 0 to EBX, 0 to EAX, and 0 to EDX just to reset everything. And because we need to use the EDX counter later for some operations, so we set it to 0 first. And also the EAX counter is also going to be used for operations, so we set it to 0. And then in my second loop, what I did was to the EAX register, I added what would be in the first value of the hello array. And then I add 4 to EBX, so I offset it by 4, and I add what is at the second value to the EDX, and then I add EBX by 4. So now when we carry out ESI plus EBX, it should point to the third value instead. And then it will store that value into the EAX register. So from this, the EAX register should accumulate the first, third, and fifth values inside this array, while the DX register should accumulate the second, fourth, and sixth value inside the array. And then we could keep on looping L2 3 times since there are 6 values here. And finally, we will move the value inside the EAX register into the variable total even, which is of the word size. And then similarly, we will move what's the value inside the value inside the EDX register into the total odd variable. And to write out all the results, we move we move the address of the result string into EDX. We call a new line, call write string, and call another new line. And we move the offset of even result into EDX. So this is the string. We write out the string, and the string would say some hello even index location. And then we move total even, the value inside total even, to the EX register again, and we call write decimal. And this is because write decimal only writes out the value inside the EX register currently in decimal. So we have to move the value inside total even into EAX first before we write it out to screen. And then we do the same thing with the odd result. We print out the statement here with using write string, and then we move the total odd inside EAX, and we call write decimal again and a new line character. And let me show you a demonstration of the program. So let's follow the input in the file. 20, 25, 30, 37, 34. So 20, 25, 30, 37, 40, 33. And as you can see, we've gotten all the same inputs as the one in the file, so 90 and 105. And that is the end of my presentation for Lab 3, Part 1, Program 2.
Next, we move on to Lab 3, Part 2. In this program, we have created a menu to link the previous Program 1 and Program 2. So basically, we will display a menu here and then asking the user to select 1 or 2 and direct them to either one of this program. And also we have this confirm, asking the user whether they want to continue the program or they want to exit. And also this finish will display the message, thank you, bye. And for the dot data, basically the main menu is, this is what we are going to use. And for the hexagon and hello, we already covered in the previous presentation. So since I already run it here, so okay, let me go to this one. So first in the menu, we call the clear console. We clear the output at the command prompt, and also we place the cursor at the top left. And next we move the offset of welcome into EDX, and then we write the string at output here. So this is what appear, everything about the welcome. And the last one is actually a prompt asking for the user to select 1 or 2. And then we are going to read a character. And then next we are going to compare the input with 1, and then jump to hexagon if they're equal, or we are going to compare the input with 2 and jump to odd even if they are equal. Now if my input is 1, and this should direct me to hexagon. So let's move to hexagon. Now everything in the hexagon is already covered in program 1, so we are going to skip this. Now I'm going to give input, let's say 5 and 10. And by the end of the hexagon program, the last line here, 120, we're going to jump to confirm. Now let's go to confirm up here. So here. Now in line 54, I display this line, which is here. Press Y or to main menu, or N to exit the benchmark. So I display this line asking for the user to give input, and then we read the character, we compare it with Y. If it's Y, then meaning the user wants to continue the program, so we direct it back to the menu, the same thing as what we started with. Or if the user wants to quit, we will compare with the input with N. If they're equal, then we're going to jump to finish. Now let's start with Y. So this one direct me back to the main menu, and this time let me choose program 2, and for an integer input, for example, I'm gonna give 1, 2, 3, 4, 5, and 6. And by the end of the program 2, here, we jump to confirm, which is the same thing just now. We display this line, yes or no. So this time, if I press no, and then we will have this thank you bye message at output, which is here, jump to finish. So finish is somewhere is here, and this message is thank you bye, and then we write the string at output, and we exit the program. So that's it for lab 3, and thank you for watching.